Okay, we have two more layouts to go through. One's the list view, the other one's a table view. And so we'll take a look at these guys. This is the two one. There's a table layout example and the list view layout example. So import them in. Let's look at list view first. Let me run it so you see what this looks like, and then we'll kind of take a brief run through the code. Basically just showing you how the components are put together. Not a programming class. It really can't show you a lot of the implementation details. But here's what it looks like. Popular one, along with the grid view, the list view, table view, probably the most popular ones. You've seen them around. This one's going to have the same functionality as our last one. When you click on one of these items, it says 3, 2, 1. So the toast message is just going to come up with the index value. We're going to take one component and stick it inside of another component. Same thing we did with the grid view. So maybe after the third example, you kind of see how the components fit together. And we're going to use a list adapter for this. So we're going to see how the adapters kind of change. So that's the final product. And what you want to do, a menu item. You know, it doesn't have to fill the entire parent, but this one is. We can actually get rid of the lines. We can change the styles of this if we want to as well. So here's the code. Let's take a look at the resource file. In the resource file and the layouts, we see we have a list item and then we have the main layout. So the list items is giving us an image view. Image view is simply going to be holding one of our images that we have in there. We're going to have a drawable icon as the source. Let me take a look at the picture here actually. Yeah, this is a drawable icon. Here's the source. We're going to programmatically change the images and the labels. So that's why it's just set to the, we know we have this one in your project because this is the default launcher. We're sticking it in the image view. So we're going to add an ID and we're going to call it logo for the image view. And a good question comes up sometimes when people wonder, well, where's this stuff coming from? How do I know about any of this stuff? And I've been showing you the XML code for it. What you could do though, if you come down here and say images and media, here's the image view. This is where the image view is coming from. So we can add it on, we can put an icon in there, and then there it is on our page. I don't want to really do this because I'm going to mess up my concept, but that's how we got the image view on there. If I go into the XML code and I look at it, now I have two image views. And if I want to, this is the one I just added, I could just get rid of it by doing that. And if I come back to here, I see, well, there's my image view, the original one I had in there. So a lot of these components, the web view, well, the web view I added programmatically, but the layouts, if we come up here to layouts, you see we have different types of layouts, table layouts. So you can drag a grid view layout. Do you want to install compatible? No, I don't want to. So to make things compatible. But you could put, you know, spaces in between things, table rows, all the layout components, all the field components. So take a tour through the library here. What's in the advanced? That's a new one. Sliders and things. Other components, text clock component. I just grabbed the text clock component on. If I go into this thing and down here, I should see this text clock widget that was added. These are called widgets, by the way. And you can just drag and drop and stick as whatever you want on the canvas, actually. I don't even have to remove it. I could just not save this, actually. So long story short, that's where we're coming up with all of these things. And what are we looking at? This particular one, this is called the list items. List item is going to be a subview that we're going to stick inside of the main view. We're going to use a linear layout for it. And in our linear layout, we're going to have an image view, and then we're going to stick inside of there a grid view layout. Oh no, I think I put the grid view layout in there on my own. We're going to have a text view. So same concept as before. Actually, the same example. It was just took the grid view out and put in a list view instead with the same submenu items. So, well, different. This has icon and a label. So hopefully you're getting familiar, a little bit familiar with the layout components. In the main layout here, it's a linear layout, and the linear layout is loading in a text view, and the text view is going to say hello world on it. And look at that, it looks like hello world. It is hello world. We're just going to replace it with this new list adapter that we're going to create. So this one's kind of the main one that we got when we built the project. We didn't do anything to it. It's just going to be generic. So I'm going to come up here and first I'm going to take a look at the Listview Adapter. I'm going to close this one here. Listview Adapter. So before we were inheriting from Base Adapter in the previous example, where we got our grid view that was modification of a base adapter, this one is an array adapter. So it's again a different type of an adapter, and this is the Listview Adapter.java class. This is the adapter component that's going to create our list view for us. Inside we're going to have the context and we're going to have the string or the values. This is practically the same code we just looked at with the grid view. It's practically the same thing with get the view method from the view. It's the same stuff. So every time you create a new layout that's going to be part of and inherited from any sort of an adapter, and here we're typecasting the adapter type to strings, so which is why we're using this protocol for the strings in here as the string data type for the adapter. And the strings are going to hold the values that we're going to stick in there. So this code, believe it or not, is identical, practically identical. Actually, it looks a little simpler, but it is pretty much the same code that we just looked at. We're going to load this. We're going to load this Listview adapter into the Listview example. So the Listview example activity, which extends list activity. So it's a slightly different activity than activity. It's a different variation of activity. That's actually giving us our list components, and we're going to stuff in there the list items. So we have list items that we created that we're going to give a separate format, put that inside of the list view. So, or the list activity I should say. So it's going to be list activity. We have a string 1, 2, 3, 4, which are our items that were showing up in here. Setting the context view to sample. Well, we're not going to do it anyway. We're just going to set it programmatically. We're going to set the onClick listener because we have the other one showing up. And we're going to set the onClick listener to, that's interesting. We're going to set the onClick listener to get the selected item on a string for the selected value for the string on the get list adapter, because we're replacing this with the list adapter. It doesn't really matter what's in the screen. This is not going to do anything. It's going to load the list adapter is going to set the list adapter to it. To the whatever the list adapter is going to take in the list adapter up here. Setting, where do we have this here? Set the context view to the items, list items. List items is this list items for the values. So we're setting the context here, so we're setting the context view on the other one. We could actually take that line out. It's not really doing anything. So it was just put in there as an example. But we have a hierarchy of Listview adapter that is being used by the Listview example activity that's loading the adapter to load the items into the Listview components. So then that's where we get that behavior of 1, 2, 3. So dwell on it, look at it, play around with it. You see we have the list concept. I'm not expected to actually know how to work with it at this point, but eventually you'll be hopefully having the confidence to kind of play around with it and make it into your own interface, make it into your own thing. And another note to make is that we could have one view, one activity I should say, that's listed, that's connected to a view, or an XML interface layout, and then that one can load through intent all of these other things, and we can use them all together. So we can have a main application that has a table view, a grid view, a list view, everything all in one if we wanted to. It's just a matter of keeping and let me open up the table view so you see what I'm talking about. Keeping the one-to-one relationship between, and this one is not doing it, this one just has the table view, but keeping the one-on-one relationship, if we go back to list view layout example, the list view adapter that works with the list view layout, the list view example that loads the list view adapter. That's what we're looking at here. So lo and behold, the last example I kind of want to orient you to right now is the one that is called table layout example. It's also in that downloaded file. It gives you again another choices here. Let me run it so we can see what it looks like. This one I believe is not quite as complicated, but we'll see what it looks like. We have a table that's going to come up. Find the right screen. Here's the table. One item, one row, two rows. No columns, just one column. First column, but this is dividing the rows in the table. And it's not going to do anything. Actually, this one, the first button on all of these loads a WebView application. And actually, I misled you. We only have one line on the rows, but we still have column 1, column 2, column 3. And the button components are labeled by the columns. So what we've done is created a table and populated it out with the GUI components. And it's really a different layout. So all of these are trying to achieve some sort of a layout objective. Either to give the user a table, a list, a grid, some sort of a UI to work with that gives it a little bit different than just a regular old linear layout or the relative layout. So let's see. So we have columns, 3 columns in this table actually. And if we look at the resource file for this in the layout folder, get main. We have a hierarchy going on over here. We see the outline here. We have a row 3, row 5. I don't see any of that row 4 or 5 on here at all, but we have it in the layout. So if I expand it out, I still have buttons in some of the rows, and I've set some of the button columns with it. So this is an example of why this is actually, the outline is actually kind of good, because then we can kind of visually see it. And I don't generally use any of the GUI components of this, but I can see where it would have some value. So we have a table layout in here. And the table layout, instead of the list view layout, instead of the relative linear, is just a different format where we're going to give it an ID, call it table label 1, table layout 1. And then put 2 columns in here. We have a row, and table row has a table view, text view in it, and it has a button in it. And then we have another table row, which is going to be expanded by 2 cells. So it's kind of like HTML when you can put some stuff in the cells. So table row here is going to be row 2. This one was row 1, I believe. Table row 1, table row 2. And we're going to, here it doesn't really matter. We're going to put another text, an edit text box in there, and we're going to give it draw the red line, which is where we're achieving from the view. So we're going to draw the view to DIPs, so it's just another measurement for specifying how thick the line should be. This is the red color that we gave it. And then we didn't draw lines over all the table, we just drew that one line just to give you an example of what you could do. And then the third column, and then we got the 4th column down here too. We actually have it all the way up to like 5 columns, I think, but I don't believe we're showing 5 columns. Either that, we don't have anything in it, just some buttons or something. So basically we're defining table rows, and then in the table row we're putting items in the table row. And then in the table rows we're specifying column 1 here. So layout column 1, layout column 2. So this is how we get from the row, we know which column to put it in. So here's a column 2 and column 3 from column 1, from the text. Well, this is from table row 3. So table row 3's got a text view and 2 buttons in it. Column 1, text view. Column 2, 1 button. Column 3, another button. Alright, let's take a look at the code real quick here. So most of the work is actually in the design of the actual XML layout file. And so this, as I was mentioning, is pretty small. We're not having any adapters on here. Instead, we're using a table view, which is a built-in controller. As some of the other examples, in fact, the last 2 ones we looked at, we're using a linear layout, I believe, and then we're adding the adapter to the layout. So we no adapter needed here, by the way. So we're just extending activity as normal. We have a button that we're going to create as a kind of a reference to our button component. We're going to add the listener for the listen on button. Same code as the previous examples. All of the examples in this particular set are all using the same code. They're just changing them around for the different layouts. On our button interface, when we click a button, it's going to listen to the first button and it's going to load that website. It's loading the intent. So this is just like the first example we looked at. It's going to make a lightweight intent, load the intent to load a URL that's going to bring up a web browser that's going to have the URL. We don't have a web view inside of our program. We're just going to load the web view or web browser. Dwell on it, think about it, marinate it. Eventually it might look good. So just need some marination, I think. You know. Well, after 16 hours of this, I'm going to need to marinate. You're going to be marinated enough, I think, at one point. I'm getting marinated. It's not over yet. So, all right. We are getting through everything, and we are going to hit Tic-Tac-Toe before the end of the day. And it is 3:22. So I'm half tempted to hit Tic-Tac-Toe, just because I want to make sure I cover it. And Tic-Tac-Toe is going to use some graphic stuff. And it's actually all done programmatically. We're not going to drag and drop. We don't have to use any images or anything. And I have serious doubts in the code actually working, so let's see what happens. We'll just take this with a grain of salt. I'm pretty sure the logic is programmed correctly. So let me show you what the Tic-Tac-Toe game looks like. After we get done with Tic-Tac-Toe, there's a life cycle tutorial that I want to give you, but I think we'll take a break after Tic-Tac-Toe and I'll go over some PowerPoint stuff that I need to cover in terms of some view concepts. And then we'll hit, I think we've already done the logging, but we'll just hit the logging tutorial. Maybe I'll just show you the final, solution instead of actually trying to build it perhaps. And then the life cycle one's worth looking at. And then we would have accomplished, believe it or not, everything that we had set out to accomplish this weekend. Or I wanted us to accomplish. So download, there's 3 files associated with Tic-Tac-Toe. And I kind of left this is the hardest one in this whole set. I shouldn't say hard. It's the most programming related one. It's all done with the programming. But it's actually quite easy. Alright, so not a GUI based, by the way. But it is GUI based. So let's just download the 3. We have an images, we have a solution, and then we have a tutorial that goes along with it. If you've downloaded it, let me shut this here. Open up Tic-Tac-Toe. Here we go. That's what the finished game looks like. I have the completed project loaded in here. We'll run it so we can kind of see what's going on. Oops, let me open it. Believe it or not, it is a working Tic-Tac-Toe game. All done without using any of the layout, which is kind of interesting. So we have the grid for us automatically. When we click on the grid, we have some really large images here. The user is hard set to be the O, the computer's the X. So I'm going to have the user win this one. And a little toast message comes up, says you win. It could say O wins. And then if you put the X's in here, we all know how to play tic-tac-toe, so we all know how to win. And now the computer wins. So it is keeping score, or it doesn't keeping. It is telling who won, but it's not really keeping score. It's filling up the whole board. So just like the one we did in the iOS class, it's very similar in terms of the logic, but it's done for Android. Yes.
Is it the same box?
Like the Android one, yes. It has the same problem as the. Excuse me, like the iPhone. Just the same logic as the iPhone program. So if you know what I'm talking about, if you're in the iOS class that I teach on Monday nights, we built this for the iPhone, and it has a bug in it, because you can switch it. All I have to just keep clicking on it. And this is the same images that someone gave me. I think you gave them to me. I don't know. Somebody found these images on the internet. Not the board though. The board is programmatic, is written a different way. I didn't have to use the board. So we have 3 images. We have a 0 space that's empty. We have a 0 and we have a plus. You gonna ask a question? Oh.
Yeah, I was just curious. So these are all line buttons you put on this thing?
Nope, they're not buttons. We're gonna see it in a few minutes. We're gonna do it using graphic libraries, and we're gonna do it programmatically without having to rely on the GUI. Which makes it very portable. We can put it on any screen we want. So this is like, oh, by the way, this emulator that you guys have is more of a tablet versus a phone, if you haven't figured that out. So If you load it on a phone, it'll be shaped for a phone because it's filling the parent. So the whole thing is going to look on it. It's going to look better on a phone, I believe, because this is stretched out, so the resolution of these images isn't that good. Let's look at the code. Let's look at the program. Actually, we'll take a look at the program, then we're going to start building the program. We have a cell, we have a circle, we have a cross, we have an empty, we have a game, and we have a main activity. Don't freak out. This one, as I mentioned before, is really utilizing proper object-oriented Java programming techniques. So you guys who are in my Java programming course will appreciate this example, because this is what we're going to be doing next weekend. Something very similar to this, using abstract-based classes and using inheritance, and then using and putting a main program. So how this works is we have one abstract-based class. It's called cell. And it's a pure abstract class. We cannot make an instance of this class. So this is a very much so an object-oriented. That's why I say some people who don't have a background in object orientation, don't have a background in Java, are going to be completely lost in this example. But those people who do, this example is for you. So we have an abstract concept of the cell. We have different types of cells. We have an empty cell, we have a plus cell, and we have a zero cell, or a O cell, circle cell. So the cell extends point, X and Y coordinate system. We're going to use a coordinate system from graphics library to implement this grid that we're going to call our playing board. In the iOS class we didn't do this. In the iOS class we just put an image of a board and stuffed it behind it, and we put buttons or images. We put sub-images on there and we did it graphically. This one's slightly different. You can do this in iOS actually, the same way. We had to change the code to Objective-C. We have one method in here, and the method's called cell, and the cell has an XY location for the starting point for where the cell is going to be pointed, where the point where the cell is going to actually exist on our grid. Abstract void draw, this is going to be the draw, the resource, and the resource is going to be an XY location with a height and a width. So we find a point, we draw the cell with a height and a width, and we stuff the image in there. But the concept of the cell is outlined in the abstract class. For people with C++ background, this is using a virtual method. And Java people, which hopefully you guys are at this point, it's an abstract class. So the abstract class, we're going to make a circle. Circle extends cell, abstract class. Cell is going to call super, send X and Y back to super, which is a cell, so that we can, and then we're going to implement the draw method, and then we're going to go down here with an equals, and we're going to check to see if the object is an instance of circle. So we're going to get the instance of, and those people in the Java class have seen this, because we're going to take the object that we're going to send to the equals and see, is this one equal to that one? Is that one, because we have to figure out what's in there so we can find 3 of them that are equal to the same thing that are going to line up in a row so we can tell who won the game. And then we're going to return O. It comes back. This is for the programming. It has nothing to do with what's going to be on the cell. Except for up here. We're going to create a bitmap image. So the bitmap image, and then we're going to draw the bitmap image. So we're not going to put a button on. It's the equivalent to the image view. We can do it with an image view. You can take the GUI and draw all this stuff out just like we did the iOS application. And if we're going to do that, then we're going to call it directly. Instead of using Drawable, we're going to take it from the layout. Harder to do it that way, I think, especially when the abstract class is being implemented. So we're going to use it from a bitmap factory decompose resources. These resources are going to be from the resource directory r.drawable circle. So we have a circle. I'm not going to go through the rest of it. We're going to do the same thing for the cross, same thing for the empty, and then we have the game logic that we're going to put in. Game logic isn't too bad, but this is going to keep track of who's winning and who's not winning. So the game is going to extend view because we're going to write the components out to the view. So we need to work with a private cell, which is a 2-dimensional grid, 2x2 array. That's going to have single space is, well, we're going to set it to null to begin with, and that's going to be the single squares that we have on there. We have an x and a y for 3, 3, an integer I, an integer a. I'm sorry?
X and Y are actually the coordinate.
The coordinate of the starting position where we're going to draw the image. Yeah. So we're going to take x and y as the corners of each one of the spaces that we're going to use in the grid. And we're going to keep track of them in the array. It's the logic of in terms of where you want to start. Where you're going to start your. We'll see it as we put it together, but you're essentially going to draw it so it fills the screen, so it doesn't really matter where you're putting it. You can start it with 1, 1 actually instead of 3, 3. We're leaving a little border around the outside of it. So that's basically. The handler is going to be our handler. It's going to take and handle the messages that are coming through, and the case is going to be from the message what is it 0, 1, 0 is invalid. 1, we're going to put a toast message out that says you won, computer won, you lost, which is essentially going to be messages we're going to send to ourselves. And we're going to send the messages to ourselves through the game logic. So set the game size return x. If we're going to set from, well, on the onCreate method here, which is going to be on touch events. Hold on 1 second. Let's scroll down to the bottom of this. Main activity, I'm sorry. Main activity is going to, I probably should have started with main activity, which is very small. Main activity is going to set the game 1 equal new game this. Set the context view to game 1. So we're making a new instance of game. Game is the logic. So the context view is set to the game itself. So we have an extremely small main activity, so which is pretty proper actually for object orientation. So the main activity, without going through the code here because I'm going to write it in a few minutes, I'm going too far into this. The main activity is going to make an instance of our game component or object. Our game object is going to make instances of the circles, the O's, and the X's. Place them on the coordinate system that we've artificially defined for our grid. And then when the things are touched on the touch events, which we can't use a button click or an on-click lister, instead we're going to use a touch control. On the touch event, which is the same for a mouse on an emulator, we're going to keep score. We're going to see who touched it. And it's based on the order of who's touching it. So the first one is fixed. The first one always comes out with an X, the second one always comes out with an O. And then X is the computer, O is the user. So the computer and the user are basically the same people playing against each other. So, which is the logic.
I was wondering,
yeah?
you had 3 messages, you win, computer win, and the third message is lose. When that situation will arise?
I don't know. Actually, I have to refresh my memory on it. We'll see it when we put the code in here. I think it's when it's a tie. I believe it might be in a tie situation.
Tie situation.
Actually, the game's up here. I can tie this one and find out.
Yeah.
So I think, oh no, which one's next? O, so we got an X, and we got an O. Lose. Wait a minute, how do we tie this? Ooh. X, O, X, O, X. Computer wins. How does that? That's logic's wrong. Unless there was something I missed. Wasn't one of the rows lined up correctly?
Yeah.
Nothing won. Nobody won that one.
Yeah.
Now let's not worry about the logic. It's too late in the day for that. What I want to do is run through the project for a particular reason. The reason why I want to do is I want to show you all of the different options you have to automate the creations of all these classes that we're building. So the idea is to kind of see how this object-oriented program fits together in terms of the way we're building this. So we can know how to build an abstract class, and we know how to build a class with an interface and all the other stuff that we're going to be looking at. Alright, so I'm going to close this one so I don't confuse it. Yeah?
Can we go to circle Java?
Yes, we can.
You have one logic where
You're still stuck on that one.
X into
All right.
R. Yeah, I mean,
No, it's okay, it's okay.
it is very interesting.
Yeah.
Okay.
So circle.java is pretty small. It's just extending a cell. So it's an inherited class from cell, and then we're setting x in the initial starting position and sending it back to, when we create the circle, we're just going to send it back, and the position we're going to send it is going to be the cell location from the point that we're going to start the building of the image back to the super, which is going to actually build the cell for us. Well, not really, but anyway. So we're drawing the canvas with the resource of the integer x, y, height, and width. So we have the point, and we're going to do height and width from the point. That's how the image is going to be drawn. It's going to be an image view that's going to be put there, and the image view is going to be the circle. So one of the things we need to do is add to the resources, and I put them in drawable. In this particular case, circle, cross, empty, and the icon for the program. So we load a bunch of images in, and then we're adding the images to the bitmap image that we're doing here. And this is not an image view, it's the raw image. And then the raw image is being put on the raw canvas using the g.draw bitmap. So you can actually play around with this piece of code and just put an image out on a canvas if you wanted to. This is the old-fashioned hello world that they do for applets. G.drawString. And you draw the string hello world, and it puts it out on a little applet screen, applet window. This is draw in bitmap. And then underneath it for the equals is just going to be a test to see, is this object an instance of circle? Return true. If not, return false. And then we're going to identify it so we can get from here on the cell for the circle, we can go toString event on it, and go 0 or O for circle. I probably should have had it come back and say 0 maybe, or circle. So X's and O's. I'm sorry, I forgot your question.
Yeah, my question was specific to that draw bitmap.
It's like drawString, but instead we're drawing the bitmap, and the bitmap's going to be the coordinate system along with a rectangle, so they're going to come out in squares. And the rectangle is going to include the height, the width, and the calculation for the new paint. It's the old style, non-Android actually. This works with regular AWT actually, with with GUI applications built for the Windows system, for the Mac system, for applets. It's just the GDraw. It's a GDraw library components from graphic, and it's graphic G. So in graphic G is well, this one is Canvas G because we're working with a canvas, which is working with a view versus a graphic. So it's a different library subset of the same component, but this is on an Android device, so we're working on the canvas instead of the graphic. In Hello World for other types, you go draw a string and you put a string in there and you give it the coordinate system to start. You find a point on the view, you start drawing the string from that point forward. With the string, you don't have a height and a width to it, you just have the string. Okay.
Where do we have the code for when we actually click on it, when we touch?
Oh, that's going to be in the game logic, and the game logic is going to be in the game class, and the game class is going to have a handler that's going to handle the messages of the touch event, and the touch event is further down on touch event. So we're going to put a touch handler, an event listener that looks for touches on the images, and they're not well, they're images. So on the images, and when one's touched, it's going to pick up the coordinates of the touch, register the event, and then go through the different logic to get the piece, draw the image. So when you touch it, there's nothing there. Well, you should put a check in there to see if it's an X or an O, and then register. So you have to get piece that's going to be run from this. Actually, the get piece isn't going to be run from this. The get piece is going to come from, it's going to draw the image, and then super on touch event's going to be handled, that's going to come back. So on the touch event, it's just going to essentially draw the image that's going to be put there. Depending upon whose turn it is, it draws the image the same way. So it's kind of a generic draw, which is why it's not, this is the method here that you would actually check to see if something's drawn there first. If it is, prevent another image from being drawn there. Ooh, otherwise it's going to essentially draw the image, and the draw on a draw it's going to be called from, let's find draw image on here.
Actually toggling from 0 to X. That's when we have case status in get image. That's where we can actually play around.
Yep.
Stop that. If it is returning 1 already.
Yep.
Stop.
We can do it in there actually as well. Actually, we could mark the locations with the XY coordinates actually. But we could keep a separate array with the coordinates along with the pieces. So validate game. So anyway, let's build it. Not a Java programming course, so I'm not going to go too much farther into this. However, it is using a lot of simplistic code that's all put together to register touch events, to trigger an action that's going to occur, that's going to find out if something needs to be painted. It's going to paint everything blindly until somebody wins the game, and then it resets everything. So it's not as intelligent as it should be for the most part. Okay, so I'm going to close the Tic-Tac-Toe game. And I want to build this only because I want to show you the different adding of the different components and where you put the components in, which is kind of the learning objective of this here. Oops, refresh. Don't want to refresh. I want to close the project. Alright, so if I bring up the tutorial, I'm going to create a project, call it Tic-Tac-Toe. I'll call mine TTT or something. And then add some images into the drawable folder of the X and Y images and program the game logic, and then run the application, which is what we're going to do. But we have to create all the different pieces, which is what we're doing this for. So open Eclipse, use Project Wizard. We're going to select and we're going to give the project name Tic-Tac-Toe. We're going to enter the following information. There's a ton of screenshots in here, which is why it's 31 pages long. It's really not that long. So, in fact, we don't even have to worry about building the logic if you don't want to, because you have the finished solution. I just want to show you how you build the classes to add the abstract class and then inherit from the abstract classes, essentially. So we're going to build a blank application, and in the application we're going to have a main activity. Same thing as we've been doing before. And if you're going to select the folder here, same thing as we've been doing before, put it in the same package. So let's build the application. And then we'll add a class to it. So let's see. New folder, other. And this is going to be an Android application project. Next. And we're going to call this, I'm going to call this TTT, because I already have a Tic-Tac-Toe. Maybe that's going to be too hard. Let's go Tic-Tac. Tic-Tac, there we go. Tic-Tac sounds good to me. Next, next. Blank activity, same thing as we've been doing before. So here's our Tic-Tac that is up here. Now the first thing I'm going to do is add the images to the project, because then I don't have to worry about adding them in the future. So how are you going to add them to the project? If you haven't realized this before, you can drag and drop and put stuff in. I'm going to click on Drawable, or I could just create a directory called Drawable, which is what I did in the other one. So I'm going to click on the resource folder. I'm going to right mouse click, then I'm going to say New, and then I'm going to go down to Folder. So this is how I'm going to end up drawing. I don't know if I've done this yet, but I'm going to add a folder in here. And the folder that I'm going to add, I'm going to click here. I already was clicked here, but this is where it's going to end up. I'm going to call it Drawable. Now I don't have to worry about which one of these is being used. And I'm going to drag the images and stick them into the Drawable folder, which means I have to find my images, which I've downloaded. They're in a zip file right here. If I unzip the zip file, I've got my images in here. When I drag them in, I'm going to copy them in because I don't want to link them, because lo and behold, eventually this folder is going to be thrown away and then the project won't work. So I'm going to take, and I have 3 components I'm going to be drawing. I'm going to draw the entire grid with empty spaces to start out with, and then replace the empty spaces with X's or O's, depending upon what's going on. So I'm just going to draw them until I've highlighted and I have a plus symbol here. And then I'm going to make sure that copy files is created. So you can change the images that you want if you want. I'm not going to put an application icon on here. I'm just going to leave it on the default. So now I have a circle across and I have an empty that are loaded into the project. Alright, I think the instructions actually have you do that last, but I don't think it really matters when we do it. At least I won't forget to do it. Now we're going to add a class to the project. Click on the project package So we've done this before already. And in fact, this is just an accumulation of everything we've done for the entire weekend. Click on the source folder, add a class to the package. This time we're going to add something to the main class package. We're going to select class. We're going to add a cell using the abstract box. So what we're going to do then is open up Eclipse here. I'm going to close this so I have a clean menu. I'm going to click on the source folder, click on the package. So I've got this selected here. I'm going to go File, New, and I'm going to do Class. I believe we've done this already. And see over here where it says Abstract, click on the Abstract button. Call the class Cell. You want to capitalize the name of the class, the first name of the file, because it's going to be saved in Cell, capital Cell .java. And the name of the class is Cell. So we're going to leave it on public, and we're going to leave all the defaults the same. If I wanted to implement this class, and this is what we saw in the Java class, we're not going to really put one with a main method in there, but if we wanted to create a Java class and put a main method in there, we could. So this is very much like traditional Java programming. Not related to Android at all, which means you could probably take this and make it into a non-Android application quite easily by changing the canvas to the another graphic device of some sort. So let's see, we have Cell. So far so good. So I'm going to go back to the PDF here, and this has got a bunch of screenshots in it. So we're clicking on public. We're making sure that we're abstracting. We have an abstract class. Now we're going to change the text in the cell.java to do the following pre-written code here. So we saw it already. We have extending, so we have abstract class cell that extends point. So right now we don't have that. We have abstract class cell. So we're going to add the line to inherit from point. So I'm going to say extends point. If I add that in, I'm going to have a little thing here, and I'm going to say import point. So I've got one of my first imports. Point gives us the ability to find on the graphic system an XY coordinate system. So we have a point. We have lines. We have a bunch of other graphic things that we can actually inherit from as well. So we're going to have a public cell, which is going to be the constructor for this here, of the same name as the class name. It's going to take on a X and a Y, so we can create a cell that has an X and a Y definition for its particular coordinate system. And then an abstract, which makes this the abstract class, is the void draw. So if I paste this in here, and now is it Control Shift F? No. What's that hotkey again? Shift Control F. Oh, I think that worked. I don't know if that worked or not. Say that one more time. Before the formatting will work? Seriously? I can remove the errors by importing the libraries that are missing. Now you're saying Control Shift? O. O? Control Shift O. Yeah, I know, I see it. Hate this. I have an extra. No? Take a look here. What did I paste in here? I have an extra. Yeah. I should just not even bother. You know what? I'm not going to bother in building it. I'm not going to bother pasting it in here. I know I'm lazy. I'm just going to build the components for you. Okay, so we added a abstract class. We put the definition of the abstract class in here. Actually, I'll do it this way. I'm going to cut and paste it from the Tic-Tac-Toe finish game, because then we can see, sort of see it come together. I won't be so lazy. It's not laziness, it's frustration of cutting and pasting and having it not work correctly. So our cell looks like this. So let me make our cell looks like this. So here's our cell. Perfect. That cut and paste works beautifully. Alright, so we're creating our cell concept with an XY coordinate system, which is our starting point for our cell. We also, and this is what makes this abstract, because if we have one abstract method in here, we have an abstract class. The abstract class is going to be void draw. So we don't know necessarily what we're going to draw. We're going to draw an X or we're going to draw an O. We don't know. So we're going to change the draw method to draw from whatever resource we decide we're going to draw. Canvas is always going to be the same. Location is going to be at the XY coordinate that we're making for our particular cell. Alright, so should not receive any error message or warnings changing your package name if you have to. So now we're going to create a new class that's going to be named Circle. This class is not abstract, but it's going to use the cell abstract class in its implementation. So here we're going to do the kind of the manual way of doing it. In Objective-C you can actually pick the subclass when you create it. So here we're just going to essentially create Circle, make it public. Don't select any of the options, but we could inherit abstract methods, if you see this down at the bottom, that would actually create it for you. If we were going to list the inheritance down here on the subclass. So we can do a couple different things here. Let me take and go back to Eclipse and File. Whoops, let me make sure I'm in the right project at least. Good, I am. So we're going to create Circle. So I'm going to go File, New, Class, and I'm going to put in here Circle. So where it says subclass here, I could change it. I'm going to leave it actually. We could use the inherit abstract method, so it would give us our method bodies for our abstract. I'm just going to cut and paste it anyway. And then we can specify the superclass. In this particular case, it's cell. That will inherit from superclass and inherit public methods. I click finished. What do I get? I get Circle here that extends cell that includes drawable. And then I get these lovely messages here that say add constructor. Yes, let's add constructor, because the constructor was missing and I should have clicked the box to add the constructor. But this one here is going to be automatically included because we have an abstract class in cell. And then we get this crap here that comes up, which is why I don't do it this way, for the resources, which I don't like. So instead, I'm going to remove Circle because the automation never really works for me quite well. So I'm going to take this one out and delete it. But if you're abstracting, if you're going to build inheritance off of pre-built objects, you can actually go through the library and pick which package you want to use, which does come in handy, so the feature does sort of work for certain circumstances. In here I'm going to go File, New, Class, and I'm just going to leave it alone. I'm going to call it Circle and take this out and just create it. So now I have a working template, and so now in here I can add the code to work from cell. So Circle's up here, and then I can say, well, I can extend cell, and then if I extend cell, it's going to come out and say there's an error message. So you have to implement the create class extend. No, so I have to look at my. Let me take a look at my extends. So I come back over here and I fix it and go extends cell, and then I can go, well, Circle isn't implementing it. Do we want to add the constructor? Sure, I can add the constructor this way, and then what we end up having to do then is eventually have to manually implement the unimplemented method. So this is add unimplemented method. Sure, why not? At this point now it works, which is interesting. So I don't have as many error messages as I had before. So both of them are accomplishing the same task. So what I'm going to do here is I'm just going to go up to Circle. I'm going to cut and paste the code and put it in here. So you can see how the project is built without having to cut and paste out of the PDF. So I'm going to go over to Circle. And I'll just take it from here. Actually, I'll just take the whole thing, actually. And cut and paste it and put it in to our Circle class over here without having to type the code in or having to paste it with a bunch of paste errors. And I believe my import resources needs to be improved because I messed this line of code up over here. There we go. Okay, so now I have a working Circle. Circle extends cell, and it implements a constructor that sets the X and Y back to, do you need this pen drive? No. Okay. Attendance maybe. Oh, do you need this pen drive? Here, just get it from me. I have it. So, I'm sorry. He's right there. I'm sorry about that. Okay. Okay. And then we have the implementation of the public void. Well, this is the method we have to implement because we are building off of the abstract class. So it's basically one way of taking and saying that each one of these methods, and we only have two, we have, each one of these classes, we have a circle and we have a cross and we have an empty. They all have to have a draw, which is why we made that abstract class. It kind of sets the contract essentially for all of the implementations. The implementations are going to be pretty much the same using different images. So here we have the drawable circle. And we're going to run g.draw bitmap to put the, as discussed already, to put the circle on there. And then we have the equals method that's in the class. So we can take this class and see, is it equal to another class? We're overriding object equals in this particular case, which is an override, which is why we get these little comments that come up in here. We're overriding object to say that if one object is equal to another object, we say object, first object is this one equal to, and then the equals is kind of like overloading operators essentially. But we're using a dot equals in that case, so this one dot equals, and then we send it that one. And we say, well, is this one an X, is this one an O? We're just testing the differences between the different images. And then the toString brings out an O if this is an O, because this is an O, it's a circle. So, alright, save this sucker. I'm going to close this circle so I don't have to worry about it. I'm actually going to close this cell because I don't need to worry about the cells here anymore either. And then we're going to do the same thing to build the next class, which is going to be the cross and then also the empty. So that will go as follows. So that was our circle code that I didn't cut and paste out of here. I have to find out a better way of formatting this so that if I'm going to cut and paste, it works actually. So now we're going to create a class and we're going to call it cross. This is not an abstract class, but it uses cells in abstract class. We're also going to do one down in here. Same method as before that is going to implement the empty. So down here, lo and behold, we have the empty. So I'm going to create cross and empty all in one shot. And then come back and start in with the main game logic. And the main game logic is going to be essentially the next step. So let me go ahead and create the other two. The other thing I could do is I could drag, oops, why do we have a message here? I could remove argument to match cell. The other thing I could do is just drag the files in here instead of cutting and pasting them in, but let's take a look at cell here. What is cell doing? What happened to my cell? I'm on my Tic-Tac, but I don't have a cell. Probably because I didn't save it. Let me copy my cell back over. There's my cell. What happened to my cell? I lost my cell. Now we save the cell. Yes. Okay, I fixed my cell. So let's go ahead and create two more classes. I can do this really quickly. Or I could take a cheat sheet method and drag and drop the classes from the other project and put it in. But it's just easier at this point for me just to create two new ones. So then I can show you how to create more classes. It's all done the same way. So file, new, other. Oops, excuse me. File, new class. And the class I'm going to create right now is, let's just do the empty. So I'll put empty in here. And I'm going to create the other one now too. So I'm going to come back up here and say file, new class, and call this one cross. And so then I can kind of do this in this assembly line process because they're both going to be inheriting from cell, so I can put extends cell on both of them. So cross I could put in here extends, if I spell it correctly this time, cell. And then up here it's going to be, well, I'm going to ignore the messages right now because I'm just going to cut and paste the code in there. So cross and then empty is the other one I want to do, and I need to change this so it says extends cell. Or I could simply just cut and paste the code, which is I think I'm going to do. So I can come down here, open up, not this one, open up the cross, take the cross code, put it into my new cross, or just drag the file over, or just use the original project. We're basically seeing how this is built. At this point, you probably have already got the point, actually. So in this cross over here, if we add the code to the cross, it's going to be very similar to the 0, actually, to the O. And except for the bottom where we're going to set the string to X. And this is still going to be the same, but we're sending the instance of cross as the class name. So is this object an instance of cross, then we know it's equal. If not, the only equals is if we have 2 O's or 2 X's. And we're checking to see if we have 3 of them in a row eventually. We're going to do that in the game logic. Well, how do we do that? We check this one, is it equal to this one? Is this one equal to this one? And then we know we have 3 in a row. Or is this one equal to this one, or diagonally, depending upon the logic of how we want to check the spaces. So we have that method equals in each one of the logics, in each one of the objects, I should say, of each one of the types to check to see if it's a cross or if it's an empty or if it's a circle. And again, this method has the same implementation, but it says cross now here instead of circle, and it's drawing the draw button again. So, all right, so cross is good. I'm going to save that one. Get rid of this cross, and now work with the empty. And so just to reiterate the point on the empty, it's the same code, so I'm just going to cut and paste it in. So empty sets the string to empty, actually. So in here, the string down here is just nothing. It returns nothing, which means there's nothing in there. We could set it, if you don't like this fact that it says nothing, we could set it to something. But then again, the code's all the same. So at this point, you're probably getting, hopefully, the idea in terms of the design pattern that's going on here. So the code that's different is going to be the game activity. The game activity is the last one we're going to create. Game activity is going to extend activity. So in our little tutorial here, if you read through the tutorial, it actually goes through the code for you. So you can go ahead and read through a slower pace. It's 31 pages of code examples. So we can build game, and in game, we're going to put the code in, and I'm going to go through the code here after I build the class. So I'm going to go ahead and click on Tic-Tac-Toe, my new one up here. I'm going to go File, New Class. I'm going to call this one Game. Probably could have called it Logic. It is the game, Logic. So I'm going to click on Finished. Now I have the game class. And so if I make it just copy this code in here and we'll take a look at it, see what it's doing. It's basically going to build our grid for us and then put the X's and the O's and the empty spaces inside. So game, oops, up to the top here, there we go. Game extends view, because game is really writing to our view. We have nothing on our XML file. It's empty, but that's our view in terms of the logic. So we have the definition of our cell for our two-dimensional grid. It's a 3x3 grid, and the X and the Y for the cells are just going to be set at 3 cells for the X and 3 cells for the Y, which is giving us our logic for our 3x3 grid. Small little grid for X and O's. We have some temporary variables we're going to keep. We have a withdrawal is false, which means we're going to play. Player wins with 3. The value is 3. We're going to accumulate values if things are equal. So if this one equals this one, we have 2. If this one equals that one, we have 3. Otherwise, we only have 2. We're not going to win. So we can keep track of the logic. You can design the logic in a lot of different ways. Depending upon the value of message what, which gets sent to the handle, which will get sent out of what happens after you execute one of the methods for the touch control, it's going to print out one of those messages, the lose, the win, the stuff like that. It's going to handle the message that we're going to send to it. So we've built our own handler called a handler. Handler equals new handler, and then we have handle the message. So it's a way of internally sending messages to ourselves to react to certain events that occur, then we're generating the events. And we're creating our own handler for it, which is the same as kind of similar to a signal handler, but it's for messages we're going to send to ourselves. Super handle messages, which we're getting that from the super class that inherited the concept of the handle message method that we're sending. So we get the game size, which is going to come from 3, and then we have the game itself. This is the constructor that's way down here that's going to send and create our object, and with a new pane, and the new pane is going to set the RGB to a certain color, the alias to a certain color, the stroke for the lines, which is how we're getting the lines actually in there. to set the style for the canvas. And then the stroke width is 5, so we can change the thickness of those lines by making that thicker than 5 if we wanted to, or make it thinner, take the lines away. So we're getting the height and the width of the game board. We're getting the squares for the cells on the components. So we have 1, 0, 0, 0, 1, 0, 2 for the 3 cells that's going across the X, and then we have the Y's that we're going to keep track of. We have our generic onDraw, which happens automatically when the view comes into existence, when the onDraw method happens. And it's going to come up and it's going to go through this here, and it's going to set the grid to single grid to define our array of cell components, which are going to be 0, 1, 0, 2, 0, 3, 0, 0, 0, 1, 0, 2. Then we have 1, 0, 1, 1, 1, 2. We have the different components. So, and then we're going to set the width and the height to each one of them. Draw it out on the board. After everything's drawn out, nothing's on there. There's no empties that are on there. But we could fill it in. I don't believe we're actually filling this in with any of the empties, which is kind of interesting. That part was left out. But then we can draw. I guess we could remove a turn by clicking on it, sending it to an empty if we wanted to build that logic in, but I don't believe it's currently implemented. But on the touch event here, we're going to draw the image, and then we're going to draw super untouch events. So on the touch event, we'll implement the X. We'll get the X and the Y where the user touched, and then we send it X and the Y to the draw image, which is going to determine are we in X or are we in O, on which order that we're clicking this with. So it's preset ahead of time. The first click is going to be the X, the second click is going to be the O. So on the draw image here, we have a is it withdrawn, which is going to be false, which means we haven't quit yet. The cell is going to be equal to new cross, and then we're going to figure out the coordinate system on the X, Y for the array that we've put together. That's going to determine, and then we're going to set withdrawn to false. So I guess withdrawn means the first player. I believe withdrawn is set to true in the beginning. Let me just check this real quick. Withdrawn is false to begin with. So I guess we're starting with an O first in this particular case. If withdrawn, else we're starting with an O. So we're starting with a draw circle. So this is how we're creating it. We're doing cell is equal to new cross or cell is equal to new circle, depending upon whose turn it is. We're setting a trigger, which is going to be 0 or 1. One of them is going to be for the X's and the other one's going to be for the O's. So we trigger back and forth. We look in the array of the grid to find the XY coordinate system of the 0, 0 to 0, 1 to 0, 2, and our positions in that particular array, which we're keeping track of. And then we're going to validate the game by figuring out if anybody won. And then if somebody won, we're going to come back and report that, and it's started all over again. So in terms of the validate game, it's a method that we're going to run that's going to essentially, if validate game, we'll go over here and validate game. After each turn, it checks to see if there's a win or a lose. And so if there's a win, then it's going to stop, and it's going to set this little toast message up that says you won or the computer won. It's pretty stupid, just going by the order of the turns in terms of the logic. So, and then lo and behold, we have the logic for the game itself. I'm not going to go through this because I'm getting kind of tired of this already, but it's going to check to see if the images are the same. Is it an X? Is this object an X? Is that one next to me? Is that one an X? If not, then don't bother. If it is, then if it's an X and an X and an X, and the object is equal to this object, it's equal to that object, which is equal to that object, then somebody has won. Well, who's won? Well, whose turn is it? In terms of the X, who belongs to the X, and so we can return the string value of it, make it an X, and say X1. So you can definitely play around with this functionality and go through and spend hours looking at the logic in terms of what's being implemented. There's different ways of doing it. Get player win is the method that's going to return the player one. Player one is going to come back all the way up to the top and run it in to print out a toast message, essentially. That is all of the components of the game. Let me just make sure there's nothing else to it. And it's kind of a long drawn out way of putting things together. But it does kind of illustrate the pattern of a normal Android application past Hello World. It's a little bit more realistic. If you go through the tutorial, it will definitely explain the code in a lot more detail too. But again, it's like 31 pages and don't necessarily want to do it. So I believe that our Tic-Tac, if I run it, it should actually work, but let's see what happens. Don't have any error messages. I believe I've actually restored it, so let's see. And that's Tic-Tac-Toe. I've got Tic-Tac coming up. Oh, here it is here. Let's see. Tic-Tac, hello world. Well, I didn't set. Let's take a look here. I probably have not set something correctly. And at this point, I'm not going to bother troubleshooting it. Oh, here it is. It's the Tic-Tac-Toe, the original one. Oops, I have all of it running. Who knows which one I'm running? Oops, let me get out of this. Let me take another look at the tutorial. I probably left out a step for the manifest, but let's just take a look here. Oh, I probably left out the main activity. I did. I did not put the method in for the main activity to make an instance of the game class to actually do it, which is why when I ran my program I had Hello World come up. So there is one more step I did not take here. Let's if I go back to the project. My main activity is running Hello World. So last but not least, after you put the game logic in, you want to change the main activity so that the main activity is making an instance of the game. So this is the method here. Actually, these are the 2 lines of code here that we're taking and creating in my game activity right underneath the activity main, which is the window that doesn't really have anything on it, but oh, that's not what I wanted to do. Edit, undo. Let's just do this. Too many windows open. Okay. Tic-Tac-Toe has a main activity. The main activity makes an instance of game. Game 1 is equal to new game this. And then set the context view to game 1. These are the 2 lines of code that I need to give my new project to say, to tell it to load the game activity and not just load main, which is the main window, which is what it normally is loading. So if I come back up here to my new game activity, inside on the create, I'm going to add in at the bottom. There we go. I need to include the game activity. Actually, I need to make an instance of it, I believe, right up here. Oops, let me go back to the main one up here. Private game, game 1. And I believe I'm going to need to include it as well. So let's see, under the activity, I'm pasting it in. And then I'm going to see, well, what is wrong with this? It's not under Tic-Tac-Toe, it's under Tic-Tac. Tic-Tac game. There we go. So now I have a working Tic-Tac-Toe game, actually, with all of those components added to it. And so if I run the application, instead of loading the main window by itself that says Hello World on it, it should load my instance of game 1. If instance of game 1 has a problem, it's going to come back with this unaccepted error, unhandled exception, and it's going to bomb out on me. So let's see how lucky I am. I have Tic-Tac, it loaded it up, and it's working. So the learning objective of this was to see how you can use an abstract base class, inherit multiple classes from it, put all the logic in all of these Java classes that are truly just Java classes. I have my one main activity class, this extending activity that's running my Android application, making an instance of it. So in essence, the only thing that's turning this into an app is this 2 lines of code here that's loading it up into my app. Otherwise, this is plain old Java code. So as an added activity, if you're interested in doing it, you can actually turn this into a swing component, or just turn it into a regular Java application. Or better yet, if you are that inclined, take the Java code, convert it to Objective-C, and put it onto a GUI in an iOS world, if you wanted to. So this is the reason why you want to learn Java. So you can build a hierarchy of classes that actually have functionality associated with it so that you can take the functionality and apply it so that you can, in this particular case, just make an instance of the object and then have the set the context view to the object, and then you can draw to the graphic UI and you can do all sorts of different things. And basically you're taking your Java skills and you're transporting them into Android as the platform. This could very well be a regular old application. So, questions on the Tic-Tac-Toe? Mostly Java code, yes?
There is some sequential thing, like once it says lose, the first time you play the game, it says lose, but then again you make a tie, and it will say computer win. And then again you make a tie, and it will say you win.
So let me see if I understand what you're saying.
So there is some
It might be a problem with the logic. Let's just see. Let's see. I can just load it up here. Let's see. Oh, that's not the one I wanted. Here, we'll just load it fresh.
Yep.
I believe I thought I was running it, but let's see. Here's my Tic-Tac. Here's the one I just built. So what are you saying? Originally, it will always say nobody lost. Who wins?
Make 3 times tie.
Do what?
Make a tie for 3 times.
A tie for 3 times in a row? So let's see if I can make a tie. X. O. X. Lose.
First time it will say lose.
Okay.
Next time it will
Tie again. I should just use the same sequence, so. O. Lose. Third time they wins.
But it didn't happen for me.
I think it's working. I don't know. There's definitely flaws in the logic. Oh, one. So the O's are the first person who goes, I think. There's definitely better ways of designing this logic. So, in fact, you can just, if you don't like it, you can just switch it. That's got to be better ways with that as well. So, we'll leave it alone. I'm going to leave it alone. Do we have any other questions about the implementation part of it? The idea was to see how the classes are used with an interface to make a non-Java program, non-Android program, just a Java program, into an Android program, essentially, is what we did here. So, all right. So Tic-Tac-Toe, do we need a break, or can we continue forward? I know they're dropping out like flies right now. Are we good? Do we need a break? Break? All right, short break, short break.